Hello, my name is Brian Manter. I did my paper and will be doing my presentation on brewery organic waste. This presentation will cover beer ingredients, making a beer, the composition of waste, traditional disposal methods, anaerobic digestion, and biogas enhancement. Beer is made up of four major ingredients: barley, hops, water, and yeast. All these added up together have a very high organic content. So the beer making process is very similar to making a tea, where you add water over your grains, collect what leaches off these grains. But after those grains have been spent, those materials have to be collected off different unit operations. Brewery waste is a lot of solids, which are the spent grains mostly. The effluent comes from the rinsing of the equipment and CIP products. But it's important to note that BOD concentration can get very, very high. What is BOD? Well, BOD is a measure of how much oxygen is consumed. So biochemical oxygen demand, as it goes up, oxidizable material goes down, which can create which creates a deficit. This deficit can be very detrimental to aquatic life. So as you see here, you have a point source. The DO in the water gets reduced, creating decomposition in septic zones, which can lead to fish kills in a toxic environment for marine life. The spent grains, as you see here, and an application in the farm, is 75% water. So 1 ton of spent grain is 177 gallons worth of water. It's a lot of water. It's a lot of water to move. So at $16 a ton to move it 5 miles, it's $0.013, but compare that to what it costs to move water from the MWA, like a Medford resident, it's 100 times more expensive. There's also the hidden cost of emissions. So a one-way trip, 5 miles, will emit about 15 pounds of carbon dioxide into the environment. It's quite staggering when you think about it. So an alternative could be anaerobic digestion. This is an image of Deer Island, the iconic egg digesters. You probably have seen these before, or if you've flown into Boston, you've definitely seen them. Anaerobic digestion occurs under environments with no oxygen. And there are 3 major stages: hydrolysis, which is the breakdown of material; fermentation; and methogenesis, which is the creation of methane. This is done by bacteria. Digester gas composition has 2 major components, mostly methane. The other part is carbon dioxide, with trace amounts of nitrogen, hydrogen sulfide, and water vapor. It's the top 2 components that are very important and people go after. So you can use the digester gas for heating, but the thing is that it's not pure gas. So you don't have the same bang for your buck as if it was natural gas. It's about 30% less efficient. There are companies out there that assist breweries with setting up anaerobic systems to create the gas, collect the gas, and utilize it. But one of the things that they don't, since the gas is very complicated, they don't really get into the fact that it's not as efficient as you'd want, and that there may be constituents in the gas that you need to scrub out or clean out before you actually burn it, because you may be polluting more than you'd want. So there's technologies such as biogas enhancement. This technology is used in many other industries. A couple technologies are anime, gas treating, and membrane. One that may be applicable to a brewery is pressure swing absorption. What makes this interesting is compactness of equipment, low capital costs, and low energy requirements. Here is an example of a pressure swing absorption unit with 2 tanks. Inside these tanks you have granular material which absorb gases under pressure, such as activated carbon or zeolite. When the pressure is released, these gases are off-gassed or degassed. And this can create very high concentrations of methane and carbon dioxide. So high methane concentration that you could actually sell it to other end users as a natural gas. Or you could use the carbon dioxide in your beer products. So in conclusion, very high organic strength waste. Conventional disposal has high economic environmental cost. Anaerobic digestion is a neat alternative when you complement that to biogas enhancement. Thank you very much.